question. This is our dreaded large data set. Um, and there is a question, well, there's two questions here that do require some very specific knowledge of the large data set to be able to get those marks. Those particular questions are only worth 2 marks. So, chances are in the event those kind of things will come up and you won't recall the specific information and they're kind of throwaway marks. I did, however, direct you to some revision over the holidays that would have meant that you were equipped to get those marks. So whether you did that and then forgot or whether you didn't do it, I can't say. But nobody got those questions right. So I'm going to guess that many of you might have not done that little revision task. Most of us got the first mark, though. Describe the correlation shown in figure 1, although I don't like the way that question is sort of nestled in between those diagrams. I think it would be quite easy to overlook the fact that it was there. Hopefully, if you did overlook the fact that it was there, you'd notice that this starts with part B and go hunting for part A and find it here. But yeah, I'm not a fan of that sort of nestling questions between diagrams. Describe the correlation shown in figure 1. If you said there was no correlation, you get the mark. Which I find more convincing than anything else because they're all over the place, aren't they? Those data points. So I would say no correlation. I think it gave weak. Yeah, you could say there's a weak correlation. Would give you the mark as well. I thought I'd seen that. Positive or a weak negative. Could be anything, which really leads me more towards the first interpretation, that there just isn't one. However, I suppose once we add in all the rest of the data, we can then clearly see that there is a negative correlation there. So then I suppose with that information informing your opinion of this diagram, maybe you would suggest a weak negative correlation. A few people did do that, and you got the mark for that because weak correlation was there on the mark scheme. We're just looking at this diagram alone, hard to see a correlation at all. Okay, part B. Explain in context what Nadine can infer about the relationship between P and T. Okay, in context, what is P? It's the daily mean pressure. In context, what is T? It's the daily mean air temperature. We're referring to figure 2. Doesn't really matter. They're still the same variables. Okay, daily mean pressure, daily mean air temperature. We can see now that there is a negative correlation. That means, in context, that as the pressure increases, I'm really bad at writing with this tablet. I don't think it's as sensitive as it might be, because I see some of you guys writing on tablets in class and have the most amazing, beautiful handwriting on it, but I guess they're just better quality pieces of kit. So as the pressure increases, the air temperature decreases. That's an explanation in context of what that negative correlation means. Decreases. We've discussed this many times in lessons. Yeah, there's a difference between describing a correlation, which is just stating what is the correlation. It's positive, it's negative, it's weak, it's strong, and then explaining in context what a correlation means. So you've got to do it. It's only a 1-mark question. So if you don't do the job, you won't get that 1 mark. There's no mark in the mark scheme for this question for saying negative correlation. We can see there's a negative correlation. Tell us about what that means in context. Okay, part C. Here's our specific knowledge. Using your knowledge of the large data set, state a value of P. Oh my goodness, what have I done? Stated value of P for which interpolation can be used. Interpolation, of course, is when we're reading from within the data range that's on the graph. Extrapolation is when we extend out beyond the range of our data. So, we're broadly then looking for a daily mean pressure that's within these bounds of where I've drawn my line here. There's no way of just guessing that, to be honest, is there? You've got to know, which is why I said as one of your revision tasks to go to the large data set, to pick an overseas weather station, and to make a note of the variables that are measured there, because for the overseas ones it's not many, and for the particular one that you chose, what was the maximum and minimum values recorded. And that would have helped you prepare for both of these questions. If we have a quick look, here is a large data set. I've clicked on Perth there from May to October 2015. Look at the daily mean pressures, because we wanted to suggest a value for P. They're all kind of around about 1,000 and something. There's not too much variation there. They're all about 1,000 and something. Pick another one. Let's go have a look in Jacksonville. Yeah, 1,000 and something. 1,000 and something. What's the smallest one we can find? They're all about 1,000 and something. Goes down, look into the 900s here in Beijing. Goes down into the 900s. So if you guessed a figure around about 1,000, 1,010 would be quite a good one. We can see we're always a bit below that or a bit above it in many of these stations. That would be a plausible kind of figure. Anything in the region of about 1,000 would be correct. So we'll just put that, 1,000 hectopascals would be a reasonable figure which would allow us to then interpolate. And then finally, using your knowledge of the large data set, explain why it's not meaningful to look for a linear relationship between daily mean wind speed, Beaufort conversion, and daily mean air temperature. Okay, well, let's go back to the data set. Beaufort conversion. There we go. Light, moderate, light, moderate, light, moderate. It's about all we've ever got on these. Light, moderate, light, moderate, light, moderate, light, 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 moderate, moderate. It's the only results we seem to have in the internationals is light or moderate. But the point being, it's not a numerical measure. The Beaufort conversion is a qualitative variable. So there's no way you could have a linear relationship between a qualitative variable and a quantitative one. That's why it's not meaningful. So there are lots of attempts at plausible explanations about why there might not be a correlation between these things. But it goes beyond that. It goes beyond that to the fact that it's completely implausible. It's not meaningful. That's the point. They used the right word there, really. It's not meaningful to look for a linear relationship because Beaufort conversion is a qualitative variable. And that's all we need to say. So, I mean, I do understand. I absolutely understand that those kind of questions that do require that really specific knowledge of the large data set to get the marks are really hard to achieve those marks. Because it's not a lot of fun staring at that spreadsheet and trying to remember things about it. But even if you said to yourself, do you know what, if there are a couple of questions like that and they're just these 1 markers, then I'm just going to kind of let that go. It's not worth my time worrying about it. I would I would understand that point of view. I would. And if you get everything else right, then okay, yeah, those 2 marks don't really mean a very great deal, given that stats is half of 1/3 of your A level. It's 1/6 of your A level. Within the stats bit of your A level, these kinds of questions requiring that specific knowledge of the data set will be very few and far between, and usually of very low stakes. So yeah, don't sweat it. Over the course of the year, we're going to pick up some more knowledge as we go by doing other large data set questions. When we do things like correlation, regression, hypothesis testing next year, and when we do normal distribution. And you will just gradually kind of acquire bits of knowledge as you go. But yeah, I wouldn't suggest that you just sit and pore over that spreadsheet to try and learn everything there is to know about the large data set. That really would be a pointless use of time.